Welcome to 5.4, Factoring by Grouping and Other Special Forms. So let's get started with the first type of factoring. It's when you can factor out a greatest common monomial factor. Remember, monomial means one. So I'm looking for the largest item that fits into both of my terms. Remember, terms are things that are separated by addition or subtraction. Well, the largest number that goes into 24 and 32 is 8. And what's the largest x that can fit into x cubed and x squared? The largest x would be x squared. There's 2 that can fit in here and 2 that can fit in here. Remember, it's got to fit into both of them. All right, x cubed isn't the largest because it doesn't fit into x squared. Okay, so what happens when I factor that out? It's like I'm reverse distributing. So I pulled out in front an 8x squared. Now what's going to be left? Well, when I take an 8 out of 24, I'm left with a 3. 8, or 24 divided by 3, or 24 divided by 8 is 3. When I take an x squared out of an x cubed, I'm left with one of those left. Okay, then I have my minus sign. When I take an 8 out of a 32, I'm left with a 4. And when I take an x squared out of an x squared, I don't have any more x squareds left. So I can factor it into this form. I'm reverse distributing. I'm pulling something out instead of putting it back in. Now you can always check your answer by distributing it back and seeing if you get what you started with. So let's try this one down here. What do they have in common? What can I factor out of these parentheses? What can I take out that's in all three? It has to be in all three. Well, let's start with the numbers. What is a number that goes into 3, 12, and 18? And that number is 3. 3 goes into 3, 3 goes into 12, and 3 goes into 18. Now I want to factor out a negative just to show you what it looks like. So we're going to factor out a negative 3. We're going to decide what's left in these parentheses after I pull that out. Well, also, why can I not factor out an x? Well, because there's an x squared here, an x here, but there's no x here. I can't take out an x because it's not in every single term. It's only in 2 of them, but not the third. Okay, so 3 is the only thing that I can take out. It's the only thing in common between these 3. So what's left? Well, when I take a negative 3 divided by negative 3, I'm left with 1. And there's an x squared there. When I take a 12 divided by negative 3, I get a negative 4. And there's an x with that one. And when I take a negative 18 divided by a negative 3, I'm left with a positive 6. So what I want you to notice is taking out a negative, factoring out a negative number, is going to change the sign of all of your terms. Now this is positive, this is negative, and now this is positive. Okay, so factoring out a negative will change the sign, all the signs of your terms. And for time purposes, I'm going to skip this and go to factoring by grouping. Now this polynomial here, it's got 2 terms. It's actually a binomial. This is one term, and this is another. Remember, terms are separated by addition and subtraction. This multiplication holding the parentheses with the 5x squared and this multiplication between the negative 2 and the 6x minus 5, those aren't 2 separate terms. That's one term because they're a product, right? Just like 6x plus 7, that's 2 different terms. Just because the 6 and the x are being multiplied doesn't mean they're 2 separate terms. So that's one term because it's held together by multiplication. Anything held together with addition and subtraction is a separate term. So I have two terms here. And looking at these two terms, I can take something out of both of them. I can factor something out. Now, if you notice, in both of them, there's this parentheses that says 6x minus 5. I'm going to factor that out. And when I do so, what remains in my first grouping is the 5x squared, and my second grouping is my minus 2. Notice when you factor out, you're not putting an addition sign or a subtraction sign in between there. It's multiplication. They're two parentheses. All right, just like we did with our monomial, it's multiplication holding them together because you're distributing it back in to get the original, right? So on this one, if you were to FOIL these back out, you'd be giving a 6x minus 5. You'd be taking this term times the 5x squared. Oh, that's what you have here. And you'd be taking the 6x minus 5 times this term, negative 2. Oh, that's what you have here. So don't put an addition sign in between these. After you factor, it's strictly multiplication. Within your parentheses, you're going to have addition, subtraction sign, but only within your parentheses, not in between them. Now let's look at the next one. It says factor the polynomial by grouping. Oh, that's a tip that we're going to use grouping, because sometimes it's helpful to group terms together in order to see what we can factor out, in order to see what's in common between them. So we're going to use factoring by grouping, and also it helps us to put things in standard form before trying to factor by grouping. Okay, and then once you have it in standard form, you're going to be able to likely remove a monomial factor from both of them. And that's what's going to happen here. And after you remove a monomial factor, it's possible to factor out another common binomial. That's what we did here. We factored out a binomial. 6x minus 5 was in common. It's a binomial. There's two terms. We factored it out. So important about the study tip is just put it in standard form. This one's already in standard form. So let's go ahead and group things together. And what I mean by grouping together is I want to place parentheses kind of around these first two terms and around the second ones. Okay, why am I doing that? Because I'm going to be able to factor out something from these two. All right, now I can't factor out a common monomial. There's nothing I can take out of x cubed that's also in negative 5x squared, that's also in x, that's also in negative 5. Right, not everything has an x, and not everything has a multiple of 5. So I can't factor out one thing from everything. But if I group them together, if I lump them together, then I can take out something from this first grouping. What can I take out that's in an x cubed and in a negative 5x squared? Well, if you think about it, x squared could fit into the second part and x squared could fit into the first part. They don't have a common 5, right? There's not a 5 here that I could factor out. So the only thing I can do is take out x squared. And when I factor him out in front, what's left? Well, x squared take out x cubed take out x squared, I'm left with an x. And negative 5x squared take out an x squared, I'm left with a negative 5. And I'm just going to drop down this second binomial. Haven't touched it yet. Now this starts to look something like problem number 1. Okay, I put them in standard form. I factored out a common monomial. The common monomial was x squared. Now I want to factor out a common binomial. Well, look what's in common. In this term and in this term, I have an x minus 5. Remember, term 1, term 2. Terms are separated by addition signs. Okay, so I'm going to take this x minus 5 term out, and I'm going to take this x minus 5 term out, and decide what is left. So pull x minus 5 out to the front, And whatever's left gets in my next parentheses. So I have an x squared left from the first term, plus, what was the number in front of this x minus 5? There's an imaginary 1 there, so make sure you drop that 1 down. So I took out an x minus 5 to the front, and x squared plus 1 was left. This is as far as I can factor. There's nothing that I can take out of either of these that's in common. And the last one wants us to factor by grouping as well. So we want to make sure we write it in standard form, first of all. So I need the highest exponent first, 4x cubed, and then my negative 8x squared, my positive 3x, and my minus 6. And there's nothing that I can take out of every single one because this is lacking an x, and there's no number that fits into 4 and 8 and 3 and 6. So what I'm going to do is group. I want to lump together my first two and my last two. Now, let's factor out of the first parentheses, and then we're going to factor out of the second parentheses. So what can I take out that's in both of these terms? Well, I know a 4 goes into 4 and it goes into 8. So I'm going to take out a 4. I also see that they have some x's in common. At max, 2 x's can fit into both of these. So I'm going to pull out x squared. And after I do that, what's left from this first binomial? Well, a 4x cubed, take out a 4x squared, I'm left with 1x. And a negative 8x squared, taking out a 4x squared, would leave me with a negative 2. Okay, you're dividing here. A negative 8x squared divided by 4x squared is telling me what's left. Okay, so I took out of there. Now, all in one swoop, let's take out from this and put it in front of our parenthesis here. So what can fit into 3x that can also fit into minus 6? Well, there's not an x in both of them, but the number 3 can go into 3 and it can go into 6, so I'm going to pull out a 3. 3x divided by 3 leaves you with 1x, and a negative 6 divided by 3 leaves you with a negative 2. So I factored these terms out of their group parentheses. Okay. Notice I didn't put addition or subtraction in between. After you factor something out, it's always connected by multiplication. I factored it out, and I multiplied it by this parentheses. I factored it out, multiplied it by this parentheses. But I can also factor once more. Notice, here's a term. Oh, there's an addition sign. It means here's another term. What's in common in both of them? What can I take out? Right? Just like I said, this was a term and this was a term, and I took something out of both of them. I'm going to take something out of both of these. Well, notice the x minus 2 is in both of them. I can factor them out. Okay, so take out from both the x minus 2. Put it in front. You factored it out. It's going to be connected by multiplication. So what's left from my first green box? Another way to do multiplication is with parentheses. So what's left in my first green box after I take out an x minus 2? Oh, the 4x squared is left. And my second green box, after I take out the x minus 2, what's left? Oh, a plus 3. So this is as far as I can factor. There's nothing that I can take out of both of these. No number can be taken out of 3 and 4, nor can a letter like x because it's not in the 3. Same thing over here with the x minus 2. I can't factor that anymore. So far we've factored out monomials, one terms, and we've factored by grouping. Now we're going to look at a special type of factoring. It's called the difference of two squares. Now, u and v, remember they can be numbers, variables, or algebraic expressions. If you have two things that are squared and you're subtracting them, right, the difference of two things being squared, we can factor it into two binomials. The first binomial is that u value plus the v value, and the second binomial is the u value minus the v value. So they're opposite signs here, plus and minus the u and v. So in your first example, it says x squared minus 64. And it doesn't look like it's two things being squared, right? There's no square on that 64. But what's in disguise here is 64 is actually 8 squared. This is the difference between two squares. So you don't have to necessarily, this isn't part of your answer. I just want you to see that it is two squares here. So in this example, our u value, the first thing being squared, is x. Our v value, the second thing being squared, is an 8. So how do we factor that? Well, two sets of parentheses, remember, one's plus and one's minus. And then you just fill in u and v, u and v. So your u we already established as x, and your v is 8. So x plus 8 and x minus 8 is the factored version of x squared minus 64. And if you don't believe me, what can you do? Well, you could FOIL it back and check for yourself. And sure enough, it'll be x squared minus 64. Let's go on to the next one. How is this the difference of two squares? Okay, well, I see an x squared and a y squared. But remember, u and v can also be algebraic expressions, right? This is one term here. I have to treat it as one term being squared. So what this really is, 49, luckily enough, is 7 squared, and x squared is also a square. So this 49x squared altogether is a square itself. It's 7x being squared. And over here, the 81 is 9, and the y squared is y. So what I have is 9y squared and 7x squared. This is this difference, this is the subtraction between two squared problems. So let's pick out our u and our v. The u is the first term that's being squared. So the first thing being squared is 7x, and the v, the second thing being squared, is 9y. Let's go ahead and factor it. Difference of two squares has two binomials. One needs to be plus and one needs to be subtraction. And I fill in with u and my v. So I get 7x, 9y, 7x, and 9y. And that's as far as I can factor it. So our answer would not have worked if we wrote this as 49. If it was 49x squared minus 81y squared, and you guys told me that the u value was x because x is being squared, and the y value is y because, or the v value is y because it's y being squared. This would not have worked if you said that the u was x and the v was y. That's not true. When you FOIL this back out, you're not getting the original 49x squared minus 81y squared. Okay, so you have to also keep in mind those coefficients, 49 and 81, they're squares themselves. Let's look at the bottom, or the third one. How is this two things being squared? Well, this expression is being squared, but what is this? I don't see a square here, so let's rewrite it as two things being squared. The first thing being squared is x plus 2. The second number that's being squared here is a 3 because 9 is 3 squared. So I have subtraction of two different squares. The first thing being squared is x plus 2. The second thing being squared is a 3. So I'm going to write that as x plus v, or sorry, u plus v and u minus v. We know what our u and our v is. So the first u, x plus 2. First set of parentheses says addition, the second parentheses says subtraction, and then v comes next. So the v here is 3. V here is 3. Now this is something I can actually simplify because I have some like terms in my parentheses. Right? I have an x plus 2 plus a 3. And in this parentheses, I have an x plus 2 and then minus a 3. So let's combine those like terms. Right? They're just numbers that I can add together. So a 2 plus a 3 would be a 5. And in your second parentheses, you have a positive 2 and a negative 3, so that'd be a negative 1. So this is my ending result after I factored the difference of two squares and simplified the like terms. And now the last one. I have two terms here. And guess what? It's the difference of two things being squared. So I can use this chart here to help me pick out my u and my v. It's already written as subtraction of two things being squared. The first thing being squared, 3y minus 1. The second thing being squared, x plus 6. So now let's fill in. Difference of two squares can be written in two sets of parentheses. First one addition, second one subtraction. Your u comes first, so 3y minus 1. And your v comes next, x plus 6. And now we just want to simplify this. So I have a 3y minus 1 plus x plus 6. And I have 3y minus 1 minus x plus 6, which means I need to make sure they both get the subtraction. So minus x and minus 6. And from there, combine like terms anything. I can't combine a y with an x, so I can only do my numbers. So first set of parentheses would be a 3y. Then I have an x. And a negative 1 plus 6 would be a 5. My next set of parentheses, again, I can only combine the like terms. So I have a 3y, I have a minus x, and a negative 1 and a negative 6 make negative 7. And that's difference of two squares. Let's take a look at difference of two cubes or the sum of two cubes. So two different ones. The first one is the sum of two things being cubed, addition, a u and a v cubed. This one is the difference, subtraction of two things being cubed, u and v. So what are they equal to? Well, let's look at sum. It says you can break it up into a binomial and a trinomial. In your binomial, you're just going to take the u value plus the v value. In your trinomial, you need to square the u, put it in the front, square the v, put it in the back, and make sure the back is an addition sign. And in the middle, you're going to write minus a u times a v. Now the signs are important. Okay, it's the same thing every single time. Plus, minus, plus when it's the sum. Plus, minus, plus when it's the sum of two cubes. But when it's the difference of two cubes, the pattern will go minus, plus, plus. Okay? So it's still u and a v in the first binomial. Second binomial stays the same, right? U squared. The next one's u times v, and the second one is v squared. But the signs are different. So these are practically the same thing, but you need to be careful about the signs. So let's take a look at the first one. It says x cubed minus 125. Okay, so I see a different sign. I see 1 cubed, but there's no cubed over here. So let's see. Can I rewrite this as the difference of cubes? For example, 125 is the same thing as 5 cubed. Now I have two things being cubed and I'm subtracting them. That means the first thing being cubed, the u value is x. Second thing being cubed, the v value is 5. So now I'm going to fit it into this formula, not formula, but pattern, so that I get it right. So it's a binomial first and a trinomial second. I'm on difference down here because I have a subtraction sign. So I'm just going to fill in my signs. It goes minus, and then plus, and then plus. So minus, plus, plus. Okay. Now, in my binomial, it says u minus v. Well, we picked out our u value is x. That's the first thing being cubed. The v, the second thing being cubed, is a 5. Now, let's go on to our u squared. Our u is x, so I need to write that squared in the front. In the back, I'm going to write v squared. So I can write 5 squared, or I can just write 25, because eventually we're going to have to put a 25. We're going to have to simplify it. Okay, so know that I squared the 5 here. And in the middle, I need to take the u value times the v value. So u is x times the v is 5. X times 5 can be written as 5x. And that's the difference of cubes in action. Okay, so that's its factored form. We factored this into this. Next one is 8y cubed plus 1. 8y cubed plus 1. How is this a sum of cubes? Well, 8 itself is a cubed, y is a cubed, and 1 is actually a cubed, right? 2 cubed is 8, and if I cube the y, I'd get y to the third power. So this first term is 2y being cubed. The second term is the number 1 being cubed, right? Because 1 times 1 times 1, hey, gets me 1. So I have two things being cubed here, which means I know my u value and my v value. My u is 2y, my v is 1. Let's fill into our pattern here. This time we're summing the cubes. There's an addition sign, so it's going to go plus and then minus and then plus. And let's fill in our first binomial with the u plus the v, so 2y plus 1. The second one, u squared goes here, so I need to square the 2y, not just the 2 and not just the y, but everything. I'm squaring the entire u. In the back, I'm squaring the v, so 1 squared, just like I squared the 5 back here. 1 squared I can just write as 1. And in the middle, I need to take u times v, which means u is 2y times v is 1, so that'd be a 2y. Let's simplify this. Because 2y squared, we've already worked with that. Remember on power rules, 2y squared means 2y times 2y. So what do you get? You get 4y squared. Minus 2y, and drop down your plus 1. These aren't like terms. I can't combine them. I can't multiply them. It says to subtract them, but I can't. There's a y squared there and a y there. Nothing I can do. So 8y cubed plus 1 factors into this because it was the sum of two cubes. All right, the bottom one. It says y cubed minus 27x cubed. Okay, so I know the y is being cubed. What number is being cubed and what letter is being cubed over here? Well, 3 times 3 times 3 is 27, and x times x times x is x cubed. So 3x is being cubed, that entire thing. All right, I have the difference here. I have difference of two things being cubed. My u value is y. My v value is 3x. Because it's difference, I'm down here. I'm following these signs, minus, plus, plus. First parenthesis, go ahead and fill it in. Second parenthesis, you're going to square the u value in front. In the back, square the v value. And in the middle, you're going to multiply the u times the v. So 3x times the y. And let's simplify that. I can't subtract y minus 3x. Those aren't like terms. Y squared is already simplified. 3 times y times x is as far as I can go there. But 3x squared is the same as 9x squared. And again, there's no like terms for me to add or subtract in the parentheses. Okay, the last three are factoring completely. So it's going to be a combination of factoring monomials, factoring by grouping, and special factoring that we just talked about, such as difference of two cubes or sum and difference of, difference of two squares or sum and difference of two cubes. All right, in the first one, 80 isn't a square, right? It's not 20 squared, it's not 40 squared. So this isn't the difference of two squares. It's not the difference of two cubes either. 80 isn't a cube. 125 is a cube, but x squared isn't a cubed. So what can I do? I always want to factor out any common monomial first. So what number, because obviously there's not an x in both of them, so what number goes into both 125 and 80? And that would be the number 5. So I'm going to take a 5 out. I'm going to factor a 5 out of both of them. All right, pull him out in front. So what's left in our parentheses? Well, a 125x squared divided by 5, I'd be left with a 25x squared. And then the minus 80, if I take 80 divided by 5, right, because I pulled the 5 out, I would be left with a 16. Okay, so I factored out a monomial, but look in my parentheses here. I have a difference of two squares because 16 can be written as 4 squared, and 25x squared can be written as 5x squared. I have the difference of two squares where my u value, actually I want to write this for you to see. The difference of two squares here, because the first one is 5x being squared, and the second one is 4 being squared. Okay, this is our difference of two squares. So our u value, the first thing being squared is 5x, second thing being squared, our v value is 4. Now that I have that written down, remember the 5's still out in front, I'm just factoring the difference of two squares. I'm factoring the parentheses part. So go back to your rule on difference of two squares. It's two binomials, one's plus, one's minus, and u and v go in the parentheses. So two parentheses, one's plus, one's minus, and the u comes first in both of them, and the v of 4 goes second. And there's nothing I can do after that. I can't take a 5x plus 4 or 5x minus 4. I don't want to distribute that 5 back in because remember, I pulled him out for a reason. I'm factoring him out. It would make no sense to put him back in or FOIL back. I would erase everything that I've just done if I were to do that. Okay, let's look at the next one. X to the fourth minus y to the fourth. Now I have a difference here. I don't have any monomial in common. I can't take out an x because there's not an x in the y. I can't take out a y because there's not an x. Or I can't take out a y because there's not a y with the x. There's nothing I can pull out that's in common. So I want to look for a difference of two squares or a difference of cubes. Well, what we have here is a difference of two squares. So what things are being squared though? Because I see to the fourth power. Well, this can be written as x squared being squared and y squared being squared. Hey, now I have two things being squared, right? I can pick out my u and my v. The first thing being squared is x squared. Second thing being squared is y squared. So now I'm going to follow my pattern for difference of two squares. Two sets of parentheses. One's plus, one's minus. And fill in your u and fill in your v. Okay, but we're not quite done. I want you to take a look at this part. What do you notice? Yeah, it's a difference of two things being squared. So I have another difference of two squares. Now, there is nothing that we can do for the sum of squares. The only thing that we can do sum of on is cubes. Sum of cubes, but on squares it's got to be difference. Okay, so I can't do anything for sum of squares. That's already factored as far as it'll go. I can't take anything out. There's nothing in common between an x squared and a y squared. So I have another difference of two squares. And what I have being squared is I have x being squared and y being squared. And I'm subtracting them, right? So my u value, the first thing being squared is x, second thing being squared, the v value is y. So I haven't touched this guy, he's still out in front, don't forget about him. But this is now being factored into two sets of parentheses, one's plus and one's minus, because it's a difference of two squares. I'm just following the rule. So I fill in my u value, which now is x, and my y value, which here, or sorry, my v value, which here is y. And that's all I can do. I can't subtract an x minus y, and I can't add an x minus y. They're not like terms. So that's as far as I can factor it. Remember, I don't want to FOIL these back. When I FOIL them back, I just end up with the guy that I started with. So let's move on to the last one. 81 m to the fourth minus 1. I have a difference problem here, so I'm trying to think if it's a difference of cubes or a difference of squares. Well, let's look at 81. 81 isn't a cube, but it is a square, right? Because 9 squared is 81. And what squared is m to the fourth? Well, m to the second squared would give you m to the fourth. How do I write 1 as a square? Well, 1 squared would give you 1. So I have two things being squared here. So my u value, the first thing being squared is 9m squared. Second thing being squared is a 1. That's a difference of two squares, so I'm going to break it into two sets of parentheses. First one's plus, second one's minus. I fill in with u, so 9m squared. 9m squared. V value comes last, and it's a 1. Okay, let's look more particularly at the first part. It says 9m squared, but that's not a sum of cubes, right? 9 isn't a cubed number, and m squared isn't a cubed variable. So I can't do anything there, and I don't have a sum of squares, right? I only have a difference of squares. So because it's a sum, because it's addition, I need to look for cubes, and it's just not there. So let's hop over to this one, look more closely. It's a difference. So I'm checking to see, is it a difference of cubes or a difference of squares? Well, 9 isn't a cube number. Remember, it's a square number because 3 squared is 9. And m is a squared variable. And 1 can be written as a square. So again, I have difference of two squares. So let's rewrite this as two things being squared and subtracted. So 3 squared would get me up to 9, and if I squared an m, it'd get me up to m squared. And how do I make that look like a square? Well, I put 1 squared because it'd get me back to 1. So my u and my v value, my u is the 3m, my v is the 1. Remember, I haven't touched this, so drop him down. 9m squared plus 1. But this is the difference of 2 squared, so it gets 2 sets of parentheses. One's plus, one's minus, and fill in with what you know. The first part is the u, that's our 3m. Second part is the v, that's our 1. And that's as far as you can factor, because this is not the difference of squares. 3 isn't a square and m isn't a square. This is not the sum of cubes. 3 isn't a cube and m isn't a cube. So that's about all I can factor.